Hello. In this video, we'll talk about what blockchain is and how the architectural aspects of blockchain work. First, let's discuss what blockchain is. Blockchain is a chain of blocks composed of hashes linked together in sequence. So, what is a hash? Let's start with that. In the upcoming demo, there is a data section and a hash section. Even though the data is empty, there is a hash value below. In other words, it's not necessary for there to be data inside for a hash to be generated. Then, there is the part that says SHA-256 above. SHA-256 is a cryptographic system used to encrypt hashes. So, how is a hash created? Let's start with that. As I mentioned earlier, we have our data section and our hash section. For instance, when I write any text into it, you can see that the hash value changes, starting with 9F86D. If I change it, you can see that it changes according to the characters I've entered. There's an important point to note here. When I write test into the data, as you can see, it starts with 9F86D. If I change it back to test, it should start with 9F86D again. Now, these hashes need to be unpredictable beforehand, but once a hash is created, it should generate the same sequence when created again. In other words, when I write test here, it should start with 9F86. And when someone else writes test in their system, it should also start with 9F86. Now, let's talk about what a block is. As you can see, we use multiple blocks to create a blockchain, as we mentioned earlier. This is the first link in our chain, starting from block 1. Now, in the example below, you can see that there's a hash value with the first 4 digits being 0. This is a special hash. In other words, it requested a function to start with the first 4 digits as 0. Here you can see a nonce value. A hash value with the first 4 digits being 0 was obtained after 72,608 attempts. You can think of this as the number of iterations, similar to neural networks, meaning it takes 72,608 attempts to obtain a hash value, with the first 4 digits being 0. So, if I change something in here, for example, DC2CI, you can see that the feature of starting with 4 zeros has disappeared, as you can see. To achieve this, we press the mine button here and obtain a new hash value starting with 4 zeros through iterations based on the data we sent and how we want our algorithm to be. In this example, we stated that it should start with 4 zeros, so we mine the hash value. So, how does a blockchain come together? Blockchain, as you can see, starts with block 1's prev value, which didn't exist before. This is our starting point. Let's look at block 2, and you can see that block 1 starts with 00 and ends with a hash of 15783B. In other words, it's based on the beginning of prev and the end of the hash. We look at block 2 without creating the chain first. Block 2 must start with prev at 15783B. Think of this as a reference, then block 2 has its own hash value. For instance, look, 12A9B. We turn back, look at 3 blocks, see what block 2 ended with 12FA9B. Therefore, block 3 must start with 12FA9B to form a chain link. It continues like this. Currently, we have 5 blocks in front of us, and it continues like this. Now, let's say I want to change a value in the 4th block, or even in the 3rd block. Let's say I want to write test again in it. As you can see, our 5-block chain is broken because the 3rd link is broken due to a change in data. As you can see, everything has turned red. Why? Because the hash value is corrupted, the prev value is corrupted, and the entire system is affected. So, to fix this, we press the mine button here again, and as you can see, we obtain a new hash value that starts with 0. Then we come back here and we need to mine block 4 again. As you can see, the new hash value for this one ends with D90E. This time, block 4's prev value needs to end with D90E for us. Then we mine block 5 again and convert its hash value into a sequence starting with the first 4 zeros. So, how is the security of a blockchain ensured? In our previous example, let's say I write test in it again. As you can see, the hash values and prev values of the last 2 blocks have changed. Now let's say I mine this. And as you can see, we've found something that starts with 0. Both prev and hash values are now 0. So there has been a data change in the 4th link of this chain, right? So how is the security of a blockchain ensured? The system works like this. There's peer A as shown here, and there's peer B. Now, the contents of peer A and peer B are the same. You can check the hash values, both 11,316 and 83B. The system works like this. Let's say we create the first blockchain in the world and we appoint person B. Person B comes and appoints person C, who then appoints DE and so on. We start making unlimited copies of the same blockchain. Now when we look at the fourth link of the blockchain in peer A, as you can see, the hash and prev values have changed, as we changed it by adding data. When we look at peer B, we see that after we mined it, the hash value now starts with 115 dead, but the original was AE8BBC. We check it in C, and yes, it was AE8BBC. So, the system realizes that there's been a mistake in the fourth block of peer A, or an attempted hack to manipulate it. They notice someone is trying to infiltrate the system and make changes, and as a result, they remove peer A from the system. In summary, this is how the system works. This also means that the more users there are in the blockchain world, the more secure the system becomes. Of course, there are theories that emerge, such as what happens to the security of the system if someone gains control of 51% of it. There is no 100% guarantee that it cannot be hacked, unfortunately, but with the increasing number of users, it becomes nearly impossible. However, there is still no definitive proof that the system is 100% hack-proof, so the blockchain system constantly communicates with each other and obtains approvals to operate. Alright, in this video, we have learned what blockchain is and how it works. Subscribe to our channel to access our upcoming videos. Goodbye.